All right, here we are for lesson number 2 on this lesson. So GCF just means greatest common factor, looking for what can divide into each of the terms. When we can do this, it's going to make our factoring easier. So for this first one here, we've got two terms. We have 2x squared and negative 18. We can see that both of those can be divided by 2, or 2 goes into both of them. So when we factor GCF out, we pull that 2 out front because we can't actually divide by 2 because it's not an equation, but we can pull it out. We're left with x squared minus 9, and then remembering that's a difference of squares, so we have 2x minus 3, x plus 3. Here I see that 3 will go into all those as well as they all share an x. So let's factor out the 3x. We're left with x squared plus 3x minus 18. Now factoring this, we've got 1 and 18, 2 and 9, 3 and 6. We want to find two numbers that will make positive 3, so it's going to be 6 and 3. So 3x, x plus 6, x minus 3. Because that 3 has to be negative, for negative 3 times 6 equals negative 18. We'll skip these now. In class of how you do those. Repeated factoring just means, as it says, repeat your factoring. So this is a difference of squares. You can take the square root of x to the fourth, it'd be x squared. Square root of 81 would be 9. So we would have x squared plus 9, x squared minus 9. We talked about this in class, but we can't factor this anymore because it's a plus. But we can factor this one, because it's, again, difference of squares. So we have x squared plus 9, x plus 3, x minus 3. Same idea. X squared minus 1, x squared plus 1. This is, again, difference of squares. So we'll have x squared plus 1, x minus 1, x plus 1. Here, let's see, what would this factor to? 400, there's a lot of options to work with. I guess we'll just start listing them out. We know it won't be 1 and 400. We've got 2 and 200. 3 doesn't go into it, 4 does 100 times. So I'm going to say that's going to be ours because it's a plus and a minus. So both these have to be minus. So we're going to have x squared minus 4, x squared minus 100. Negative 4 times negative 100 gets you a plus 400. Negative 4 plus negative 100 gets you a negative 104. Then both of these are difference of squares. So we would have x plus 2, x minus 2, x plus 10, x minus 10. Then continue with factoring, now we're going to solve equations. So what we're using here is this idea. It's called the zero sum product, or zero product, something like that. So if we have a times b, where a and b both represent a number, equals 0, then either a has to equal 0 or b has to equal 0. Right? Because if a equals 0, then no matter what b is, 0 times whatever is going to get you 0. And vice versa. If a, or if b is 0, whatever a is, it doesn't matter because a times 0 gets you 0. So we're going to use that idea here to then be able to solve for equations. So the first thing we need, just like this is equal to 0, we need to make this equal to 0 by subtracting 20 from both sides. We get x squared plus 5x minus 14 equals 0. We factor, we get x plus 7, x minus 2 equals 0. So this now is like our a, and this is our b being multiplied together. So either x plus 7 equals 0, or x minus 2 equals 0. We solve these separately. Here we subtract 7. We get x equals negative 7. Here we add 2, x equals 2. So our solutions are 2 and negative 7. In last class, I mentioned this briefly, but when I said we're factoring, we're trying to find where these parabolas cross the x-axis. Well, this parabola here, if we graphed it, would cross at negative 7 and positive 2. So when we are factoring, we're trying to find where do we cross that x-axis with our graphs. Here we would subtract 27x from both sides to get it equal to 0. That's your first step. You got to get equal to 0. I say we have a GCF here of 3x. So we pull the 3x out. We're left with x squared minus 9 equals 0. So then we have 3x, x plus 3, x minus 3. All three of these are zeros. So each one of those will make equal to 0. We have 3x equals 0, x plus 3 equals 0, x minus 3 equals 0. So our roots are at 0, negative 3, and positive 3. For your homework, you can just list it from least to greatest. Negative 3, 0, 3 for your answer. So we talked a little bit about rational expressions already. It's just when you've got a fraction such as that with x squared plus 1 over x plus 2, something like that. One thing to remember here that we're going to have to keep track of is that we cannot divide by 0. So for this rational expression here, our domain, we haven't talked about domain in a while, but domain is all the possible x values. For a graph, our domain would be everything except x could not be negative 2. If we plug negative 2 into this rational expression, we'd have negative 2 squared plus 1 over negative 2 plus 2. Simplify the bottom, or we get 4 plus 1 over 0. And right there, we see we were dividing by 0, which we can't do, so x is not allowed to be negative 2. So right now, the only restrictions we have is whatever might make the denominator 0, x can't be that number. So to start, we're going to check each of these. X can't be negative 5. X can't be positive 5. And then this encapsulates both of those. I'm going to factor that denominator real quick. So we'll have 2 over x plus 5 over x minus 5 minus 10 over x plus 5 x minus 5. So I see here, to be able to combine these together, we need the same denominator, and our common denominator is going to be this, because this has a plus 5, this has a minus 5, this has both a plus and a minus. So we're going to multiply that first fraction by x minus 5 over x minus 5. The second fraction, we're going to multiply by x plus 5 over x plus 5. And the third fraction we just leave like it is. Okay, coming up here to the top over here, we'll have 2x minus 10 plus 5x plus 25 minus 10 all over that x plus 5, x minus 5. So we turned each of these fractions into that x plus 5, x minus 5, which made it then possible to combine the tops. And all we did was did 2 times x to get 2x, 2 times negative 5, 5 times x, 5 times 5. Combine the tops, or simplify, so we get 7x plus 5 over x plus 5, x minus 5. Same idea here. I see that this is going to break up into x minus 2, x plus 2. X here cannot be a negative 2 or positive 2. So we're going to do the same thing, multiply that first equation by x plus 2 over x plus 2 times x minus 3 over x minus 2 plus, and we'll do x minus 2 over x minus 2 times x plus 3 over x plus 2, and then we'll keep the last fraction as it is, 4x plus 3 over, and then we can do this, x minus 2, x plus 2. So now, on top, we're going to need to FOIL this stuff out. So we'll have x squared minus 3x plus 2x minus 6, that's this first one, plus x squared plus 3x minus 2x minus 6, that's that second one. And then this subtraction sign makes the 4x and the 3 opposites, so it'd be minus 4x minus 3 because you're now subtracting them, all over x minus 2, x plus 2. Combine like terms. I see we got a minus 3x and a plus 3x, those cancel each other out. A minus 2x and a plus 2x, those cancel each other out. And so then we are left with x squared minus 4x, and then 2x squared actually. So we've got 1 here, 2 here. We've got 1 negative 4x, and then minus 15. All over x minus 2, x plus 2. We'll check to see if this is factorable. We would have 1 and 15, 3 and 5, 1 and 2. We're trying to make negative 4. And it doesn't look like it is factorable. So this would be your final answer. You don't need to expand this back out. You can leave it as it is. No reason to do extra work. All right, couple more. So here we're dividing. So remember, if you remember dividing a fraction by a fraction, it's the same thing as doing 1/2 divided by 3/4. And it's keep the first fraction, change, division, multiplication, flip the second fraction. So we took this fraction here and we flipped it. We can do that same thing with rational expressions. So we would rewrite this as 2 over x times x plus 1 over 3. Multiply straight across. So it would be 2x plus 2 over 3x. And now we can't simplify anything because we do have 2 x's, but we're missing an x here. So everything has to share for it to be able to simplify. So our final answer would be 2x plus 2 over 3x. That's the same. A little bit more complex, but still same idea. 2 over x times x plus 1 over 3. Problem. That's embarrassing. We'll skip that. Here we are for this fun one. So we're going to do two things at once. So we're going to factor each of these. So that's going to factor to x plus 1, x plus 3 over, and then we've got x plus 2, x plus 4, and then we're going to multiply that by this bottom one. So that's going to be x, let's see, x plus 4 x minus 1 over x minus 1, x minus 1. Or, sorry, that's going to be x minus 2, x plus 1. So before we get going, we can simplify since it's multiplication here. Anything that's on the top and bottom, we see we've got x plus 1 and x plus 1. Those cancel out. So we've got x plus 4 and x plus 4. Those cancel out. So that leaves us with x plus 3, x minus 1 over x plus 2, x minus 2. There are some extra assignments I will post as well, the systematic reviews. I'm not going to make those required, but if you feel like you need more practice on this before your test, then feel free to do those.